Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics State Trial Exam paper. This is for Kedah, paper 2. Okay, let's get started with question number 1. And now in this question, you have two rectangle ABCD and PQRS. The perimeter of ABCD is given as 36. And there's a mistake in this question here. The length of diagonal, not AC, it is SQ, because if you use AC, you wouldn't get an answer for this. I think the question is meant for SQ, not AC. So please take note. So here, perimeter of the rectangle is 36. So that means we know that if I take rectangle ABCD, there are 2 of x and there are 2 of y plus 8. So we say 2x plus 2 of y plus 8. Your outcome must be 36. So let's take this and divide everybody by 2. As I divide by 2, I get x plus y plus 8 equals to 18. Now here you can choose to make one of them as a subject, either x or y. Maybe I just make y as subject. Y will be 18 minus 8, which is 10 minus x. Just bring to the right, bring the x to the right-hand side. So that will be my equation number 1. So for my second equation, I'm supposed to find, or should I say, use the relationship between x and y in the rectangle PQRS here, because your diagonal SQ, this is SQ again, once again, it is 2 sub 13. So I'm going to say x squared plus y squared, if I put a square root here, is now 2 square root 13. So let's square both sides. 2 squared is going to give us 4. Sub 13 squared is going to give us 13. So your x squared plus y squared is now 52. Yeah, if you're not sure, you can just use a calculator. Now, let us now sub equation 1 inside equation 2. The moment I sub in, I don't write y anymore. I write 10 minus x, and I square it. The result is 52. Let us expand this. X squared plus 100 minus 20x plus x squared equals to 52. Add the x squared together. X squared plus x squared is 2x squared minus 20x. 100 minus 52 is us 48. Right. So in this case, we should use a factor combination that gives us 48, but I think we can divide by 2 first. And you notice all these numbers are divisible by 2. When I divide by 2, x squared minus 10x plus 24 is now 0. We work out the factor of 24, 24 and 1, 12 and 2, 8 and 3, 6 and 4. And the one that gives us 10 should be 6 and 4. So I'm put double bracket here. So we have x, 4, 6. They are both negative. Minus 6 minus 4 gives us minus 10. So x is either 4 or 6. Okay, the next question is, which answer should I find? Should I use? I got 2 answers for x and y, so we don't know, right? We have to sub inside equation number 1 and see which one gives us the correct value. 6 and 4. 6, 4 gives us 10. Correct. So your y is now 10 minus 4, which is 6. Or y is now 10 minus 6, because for the 2 answers. So since x is a length, right? So x should be 6, right? X is greater than y. So x is 6, y is 4. But I'm not done yet. I need to find the length of AD plus SR. AD is your y plus 8. SR is your x here. So your AD plus SR will be y is 4. 4 plus 8, which is 12. You add with SR, which is 6. Answer is 18 cm. Right. Okay, moving on to question number 2. This is from the chapter, Form 5, chapter 2, differentiation. So you're given the equation of a curve y equals to 2 x minus 3 with a bracket power 4. You're first supposed to find equation normal. Okay, first step, let's differentiate dy dx. When we differentiate this, remember this is a bracket. We use the composite function formula. You transfer the power down, copy the bracket, reduce the power by 1, you get 3, differentiate inside the bracket, you get 2. So yeah, let me write down the formula if you're not sure. If you have y equals k fx power n, when you differentiate, you transfer the k, the n in front, and multiply with k, copy your bracket, reduce the power by 1, and differentiate whatever inside the bracket. Now here in your bracket, you have 2x minus 3. If you differentiate, you get 2. Now, next we have to substitute x with 1 because you're finding equation of normal at x equals to 1. So let us sub inside. Now, you can actually multiply this. 4 times 2 is 8. Put 1 inside the x here. So this will give us 2 times 1, which is still 2. 2 minus 3 power 3. 2 minus 3 is negative 1. Negative 1 power 3. That will give us negative 1, right? Negative 1 times 8, negative 8. Remember, when you differentiate and substitute the x value, what we're getting here is a gradient of tangent. And since you're finding equation of normal, we have to first find gradient of normal. Now, let's say you have a curve like this. A line that touches a curve at one point, this line is called a tangent. A line that is perpendicular to your tangent is called your normal. So you're forming equation of normal. So we know tangent times normal. If you multiply the gradient together, the result is always negative 1. Yeah, m1 dot m2 equals negative 1. Therefore, my gradient normal is 1 over 8. So to find equation of normal, let me write over here. I just use the formula y minus y1, mx minus x1. My y1 is now negative 3. My gradient is now 1 over 8. My x1 is now 1. So for me, I multiply the 8 over 8y plus 24 equals x minus 1. Rearrange it. 8y equals to x minus 25. Now, up to you. You can actually stop here. If you divide by 8, also can. Like some students prefer to divide by 8 and change to what we call the gradient formula. But if you don't do that, it's fine. 1 over 8x minus 25 over 8 also can. Right? All right. Now, what we're going to do over here, I am finding the value of m given the gradient function of this. Now, it's unrelated to the first one. When you're given gradient function, that means your dy dx is 3x minus 3 over x squared. You're supposed to find the value of m given that it has a turning point at m and 7. Now, we know at turning point, be it a minimum or maximum, the gradient is always 0. The gradient of the curve at that point is always 0. So we sub dy dx with 0 when x is m. So we can substitute m inside, right? At turning point, dy dx is 0. Your x value is m because it's given here. Yeah, there's a turning point. So what I need to do is to rearrange the equation. Maybe I bring 3 over m squared to the left equals to 3m. Bring the m cube up, bring the 3 down. 3 over 3 is 1. This is m cube. Cube root of 1, m is still 1. Okay, now that I know the value of m, I can now determine whether it's a minimum or maximum, right? So this is only part 1, Roman 1, B Roman 1, B Roman 2. To determine whether it's minimum maximum, we have to do what we call second order differentiation. So we take a dy dx, you differentiate one more time. When I differentiate 3x, you get 3. Differentiate this, you get positive 6 over x cubed. Now, for those who are not familiar, I always differentiate reciprocal form like this because it's faster. I put a negative in front. I take a times n, an, copy x, increase the power by 1. So this is the method I use. It's a lot faster because I know a lot of teachers in school will ask you to bring it up, differentiate, bring it back down using the general form method, but that is a bit slower. We put a negative in front. So originally there's a negative here. Notice I put a negative in front, become positive. Then I take 3 times 2. 3 times 2 here gives us 6. Yep. Then I increase the power by 1. I get 3 here. Notice that. And then differentiate inside. And that's it. The power 3. So let us now pick the x value. Your x is 1. Your m is your turning point. X is 1. Put this inside here. So this will give us 3 plus 6 over 1. 1 power 3 is still 1. Now, the exact value is not important. What we are interested in is the sign, whether it's more than 0 or less than 0. In this case, it's 9. It is more than 0. So therefore, this coordinate is a minimum point. Yep. Okay, moving on to question number 3. This is from the chapter Coordinate Geometry. So here we have a diagram that shows a straight line AC and CD. B lies on the straight line AC, where C lies on intersection between AC and CD. They're all given here. The north direction is parallel to the y-axis. So here we have to use a bit of concept of bearing that you learn in geography. Bearing of point A from B is 315. Now remember, bearing works a bit differently from trigonometry. In trigonometry, we measure from positive x-axis and we measure in the anti-clockwise direction, right? This direction up. So, but in bearing, we measure from north and we measure in the clockwise direction. So when we say bearing of 315, this is bearing of A from B. So B is your reference point. Imagine north is here. We go this direction 315. So if you take 360, you minus 315, the angle that we have here is 45, right? So we know this is 45 here. Let me just label here 45. So now up to you, you can actually use tangent 45 from here, or some student may say, can we, because we are now finding the gradient, right? And we know gradient is actually the gradient of a straight line is actually a tangent. Okay, now for those who don't know, when I draw a triangle here, let's say this is theta. Tangent is your opposite, which is your change in y, divide by your adjacent, which is your change in x. Yeah, or we can say delta y over delta x. So in this case, your tangent theta is delta y over delta x, which is your gradient. So here the angle is 45. So this is 135, right? So you can use tangent 135 equals to this your gradient. And if you use your calculator, tangent 135, calculator, tangent 135 is just -1. It is -1 because it's in quadrant number 2. Yeah, quadrant number 2, tangent is negative. If not, you can just use your calculator. Yeah. So in this case, gradient of AB, or you can say line AC, I'll just write line AC, is now -1. So alternately, some of you may say, oh, can I just say this is 45 and I write tangent 45 is my gradient is 1, but since it's on the left-hand side and you can see it's going downwards from left to right, then I just add a negative here, so gradient is -1. Yeah, you can do that as well, right? We know if it's going uphill from left to right, you're climbing uphill, the gradient is more than 0. If you're going downhill from left to right, your gradient is less than 0, it's negative. Okay. So we're supposed to find equation of straight line AC. I've already got gradient AC. To find equation of straight line, I need a point. I know we could use y minus y1 and x minus x1. The point that I have, point A, is -2, 4. So y minus 4, gradient -1, x minus -2. So your y is now minus x minus 2 plus 4. Bring the 4 over, y is minus x plus 2. There you go. This is your equation of straight line AC. Okay, next I want to find equation of straight line CD. Now you're given that this is perpendicular, 90 degree. So whenever you see 90 degree, we know we have to use m1 dot m2 equals to -1. So my gradient of AC, we know, is -1. Your gradient of CD, I don't know. I put MCD. The result is -1. My gradient CD is therefore just 1. Okay, I know gradient CD, right? But I know it also passes through point D. So in order to form equation of straight line CD, I have to use the formula again. This formula, let me highlight here. The formula to form equation of straight line. Y minus y1, I use point D. D is 0. Your y is 0. Gradient is 1. X1 is 4. Your y is x minus 4. There you go. This is your equation of straight line CD. Okay, next, I want to solve the coordinate point C. So first we find equation of straight line CD, then we solve for point C. Now, how do you find the coordinate intersection? We call this equation 1, equation 2, because we know AC and CD, they meet. AC and CD, they both intersect at point C, right? So we just call this equation 1, call this equation 2. We sub 1 in 2 or 2 in 1, doesn't matter. So minus x plus 2 is now x minus 4. Bring over. Your 2x is now 6. X is now 3. So I need to find my y value as well. My y, I sub inside equation number 1. Your y is minus 3 plus 2. Your y is negative 1. Therefore, your c is 3 minus 1. Okay, I've got coordinate of point C. Now, next, state the equation locus whose distance is always equal from B and D. Okay, constant distance from two fixed points is actually what we call perpendicular bisector. When you have an equidistant from point B and D, they are on the same x-axis or parallel. Yeah, they are on horizontal line here. So your perpendicular bisectors should be right in the middle. Now we already know coordinate point D. D is 4, 0. And we know C is 3, negative 1. And B actually you can find, not difficult. Okay, this is just for confirmation. You can see it's only 1 mark given for part C. For confirmation, we know from equation number 1, at x-axis, your y is 0. Equation 1 is your straight line AC. At x-axis, y is 0. If I let my y be 0, your minus x plus 2 is 0. X is now 2. Therefore, the coordinate of point B is 2, 0. So B is over here, 2, 0, right? And D is 4, 0. So if it's a perpendicular bisector, it must cut right in the middle, right? So this line, this vertical line, must pass through point C. And therefore, we know your x equation of this perpendicular bisector is a vertical line. It's just x equals to 3. Remember, if it's a horizontal line, we say y equals a constant. It's a vertical line, x equals a constant. It's just x equals to 3. There's nothing else you need to do. Don't have to use, I know some people may say use B equals B, what do you call that? PD, use the equation locus. You don't have to do that because we already can see from this diagram. Yeah, this will be your perpendicular bisector. And since it passes through C, the x coordinate point C is 3. So the equation is just x equals to 3. Okay, moving on to question number 4. This is from the chapter, chapter 1 function. So here you're given a diagram that shows composite function. This composite function, if you have k first followed by h, we call it hkx, because you're starting from x. So you're given h inverse, right? You're supposed to find the value of p. Now, p is actually the result of k function kx, right? It maps x onto px. I think the first thing I will do is I'll find out what is my hx. Now, for when you're given h inverse to find hx, remember it's just the opposite operation. For a simple function like this, you don't have to use the long way of inversing a function. We know that when you inverse a function, it's just the opposite operation. So what is the opposite of x minus 3? Answer, x plus 3. That's all. When you inverse hx, is h inverse x. If you inverse x plus 3, you get x minus 3. If you inverse x minus 3, you get back your x plus 3. Yeah, we can just write this in one step. Now, the next step is we know your hkx gives us 2x plus 3. And we know our kx is px. Based on the diagram, you can see when you map x onto, we go through function k, your x is mapped onto px. So I'm going to sub this inside. My k is px. The result is 2x plus 3. And I take this as sub inside. H, remember, think bracket, h bracket is bracket plus 3. If you put px inside, I will write px plus 3. So let's write px plus 3, and the result is 2x plus 3. From here, very simple, we just compare. By comparison, your p is just 2. Yeah, very simple comparison will do. Okay, let's move on to part B. Now you're finding k2x. Now remember, k2x doesn't mean kx squared. It's not square. K2x means the function k repeat itself. Yeah, we do kx twice. The first kx, as we know, my kx is px. I am going to sub b with 2. So I'm going to put the 2x inside. So this will be k bracket equals to 2 bracket. If I put another 2x here, I should put another 2x here. So it's going to be a 2 of 2x, which gives us 4x. Yeah. So end result, k2x is just 4x. Next, I'm finding function k and x. Okay, before we do k and x, right, let's try it out with more function. Okay, so we just do k3, right? K3 simply means k2 kx, or you can write k2x, up to you, right? Like some student may say, I do k2x also can. So the thing is, what's your k2? My k2 is 4x. My kx remain the same. If I put 4x here, I must put 4x here. So this will give us 2 of 4x, which gives us 8x. Now we can go on and on, but I hope you can see the pattern already. Yeah? The first one is, if your kx is 2x, your k2 is 4x, your k3 is 8x. If you're not sure, you can do one more. K4. K4 is what? We can write k, maybe I put k of k3x. We know k3 is 8x. So again, if I put 8x here, I must put 8x here. So this will give us 2 of 8x, which gives us 16x. So there is a pattern that we can see here. Kx is 2x. K2x is 4x. 4x is basically 2 power 2x. And maybe I write here this as 2 power 1x. And I know k3x is 8x. 8 is 2 power 3x. K4x is 2 power 4x. This is what we call making conclusion by induction in your normal maths, right? The mod maths logical reasoning. So your k and x therefore gives us 2 power n times x. Okay, question number 5 is from the chapter Trigonometric. So from 5, chapter 6. Okay, so the first part, you're supposed to prove that 1 plus cos x divided by sine x, this is cotangent x over 2. Sorry if it's not very clear here. So, okay, I'm going to do the proving over here. We start from the left-hand side, okay? Now, when it comes to proving, we can start from the left, but it doesn't matter, start from the right also can. But we want to start from the side that has more number of terms and then work towards simplifying it, okay? So the one on the left has more number of terms. Okay, now a couple of things about the formula for cos. We know cos 2a is, there are 3 versions. We can say the first version is cos square minus sine square. The second version is 2 cos square a minus 1. The third version is 1 minus 2 sine square a. So which version to use here? Okay, now number 1, take note, instead of writing 2x, we can let, or 2a, we let this be x, right? So we're going to change this to a single x. Let me write here. This is x here. In this case, this should be x over 2 minus here, minus sine square. This is x over 2. Just change all this. We call it the half angle formula. So notice whatever I have on the left is still double whatever I have on the right, right? So cos x is cos square x over 2 minus sine square x over 2, or 2 cos square x over 2 minus 1, or 1 minus 2 sine square x over 2. Okay, you can see on your right-hand side I have cotangent. So I got this problem. Which formula do I use? Well, we know that cotangent is cos over sine. So that means I have to use the formula involving cos. At the end result, I must have cos. So I'm going to use this one, right? So let us say 1 plus, instead of writing cos x, I'm going to write 2 cos square x over 2 minus 1. Okay, how about my denominator? My denominator I have sine x. Now again, go back to the formula for sine 2a is given as 2 sine a cos a. But instead of writing sine 2a, I write sine x, right? If this is 2a, this is a, right? So half of it, a is half of the left-hand side. So x is on the left. Right-hand side, I must write x over 2. And this is cos x over 2. Okay, next, I'm going to put this inside here. 2 sine x over 2 cos x over 2. The 1 minus 1 I can cancel. This one I can cancel, see? Can cancel them, right? I'm left with 2 cos x over 2. Sorry, there's a square here that I missed out. There's a square here, sorry. Cos square here. Divide by 2 sine x over 2 cos x over 2. Can we cancel cos square and cos? Cos square and cos cancel. Can we cancel 2 and 2? Now I'm left with cos over sine, right? This is cos x over 2 divided by sine x over 2. So yes, this is the same as cotangent x over 2, which is the same as your right-hand side. Yeah, it's not too difficult. Right? Okay, that is the first part. Okay, second part, I'm going to draw the graph maybe on the right-hand side. I'm going to draw a bigger version on the right. But first, let's do some basic sketch first, because I want to draw -2 cos x plus half. But let's start with the basic cos x. The basic cos x graph looks like this. It goes down and up, maximum 1, minimum -1. This is from 0 to 2 pi. But take note, I'm not drawing from 0 to 2 pi. In fact, I'm drawing from -pi to pi. So I just have to extend to the left over here, down here. This is pi. This will be -pi. So the graph that I'm drawing is 1 and 2. I don't need anything more than that, right? I need this only, right? So number 2, let's do a -2 cos x. The negative in front means I have to invert it upside down. Instead of going this direction, it goes the opposite direction. That means we have -1 here. When you multiply -1 here by -1, it becomes +1. So this is +1, this -1. So the graph will now go downwards. Okay, I think I did too fast already. Sorry, guys. I say wrongly. My cos, okay, maybe I, okay. I hope you're not confused when I draw this too early, because you look at this and wonder this is negative cos. Okay, maybe I extend this first. Okay, sorry guys, I extend this first. This is easy to understand because you are familiar with this shape, right? This is the graph of y equals cos x. The moment you have a negative in front, the graph will be upside down. So it goes like this and like this, correct? However, we need to multiply by a 2. So my maximum is now 2, minimum is -2. Okay, so this is still pi, this is still 2 pi. Okay, but I don't want this. I want to draw from -pi to pi. So I would extend this graph to the left. So yeah, we go down, up, like this. Okay, so this part is okay. My minimum is 2, minimum is -2, maximum is 2. But for the last part, I need to add a half here. So when you add a half, you're gonna shift up by half, right? Yeah, I'm gonna shift up by half. So the graph will be shifted up. Okay, so when you shift up by half, my maximum will be 2 plus half is 5 over 2. My minimum will be -2 plus half, minus 3 over 2. So let's say this is your middle line. The middle line here will be half, right? And my x-axis should be around here. Maybe extend this a bit longer. This is -pi. This is pi. This is -pi over 2. Pi over 2. I just draw a bigger version. Okay, we know that initially we start here. This is second point, third point, fourth point, and fifth point, right? Remember with the curve this way down, this way down, this way up. Oh, this is a bit ugly. Let me fix this. And oops, still ugly. Okay, this is better. And then curve it this direction. Okay, so this is your y, this is your x. and my graph is done, right? Okay, moving on to question number 6. This is from the chapter linear law. So here we have two quantities, x and y. They are related by the equation r over tx plus square root r, where r and t are constant. So you're already given a table of values, and this value here already calculated x, y. So you don't have to like convert this to linear form. You don't have to recalculate your x, y. So here we're plotting x, y versus x. Can you see? Plot x, y against x. So your horizontal axis, you can see is x, the largest value is 6. So I think I do 0, 1. This will be 2, 3, 4, 5, 6. The largest, this will be your x. And your vertical axis, the largest is 42. So I think we can do 5. Yeah, 5, 10, 15. A bit hard to see. So I just zoom in a bit. So this is 10. This is 15, 20, 25, 30, 35, 40, the largest 45. This is 40. Largest value, we can go up to 45 because we have a largest value of 42. So this will be your x1. Okay, maybe I should highlight or label my horizontal and vertical axis, easier to see. Label here. This is my x axis. Just adjust the line. Okay, this is my x-axis. Then draw another one, your y-axis. Start from here all the way up. Okay, up to 40, 45. Yeah. Okay. All right. Okay, let me adjust a little bit. There you go. Okay, now the next thing is we are finding the line of, we're drawing the line of best fit. Plot the point first. The first point is 1 and 19. 1 and 19 will be here. Okay, 2 and 26 will be here. Remember, the scale is 1 is to 5. One big box is to 5. One small box is 0.5. So if it's 26, you have to read 2 boxes up. Next, 3.2 and 32. 3.2 is here. 32, you need to go 4 boxes up over here. Next one is 4.5 and 35.1. 35.1. 4.5, 35.1. 4.5 is over here. 35. Okay, this is 35.1. You need to read 35. Because 30, we can't read 35.1. I can write 35.5. So we should label it here. It should be closer. Okay, I wonder whether my graph is all right because my first point is a bit off. No, 20, 25, 20, 26, 2.5. Okay, I made a mistake in 2.5. 2.5 is supposed to be here. 2.5 and 26 should be here. Okay, next we do 4.5, 35.1. 5.5 will be 39.88. We should use 40. Yeah, 40. You can read 39.5 though. 35.88, maybe you can read 39.75 because remember this is 39. 39.5 is in between. 39.75 is even is half of the smaller box. So okay, I'll read 5.5 and here slightly below, yeah, put a cross. And the last one is 6 and 42. 6 and 42 should be this value here. Okay. All right, I know a bit hard to see. I find it a bit hard to see myself. So, okay, I think it's okay. I will label here. Now, let's just draw the line of best fit, okay? 5.5, I hope everything is okay. Let's draw the line of best fit. Again, the last one is a bit off. Okay, sorry, let's do one more time. Okay, what happened? Okay, one moment. Yeah, I think my 6 is a bit far off. 6 is over here. 42 is here. Okay. Now let's draw the line of best fit. Okay. Again, a bit hard to see. My graph a bit small. Let me just adjust it a little bit. It's over here. Now let's draw your straight line. Okay. We're gonna draw a line like this. Okay. We may have to adjust it. Let me zoom out a little bit. Adjust this line. Make sure you pass through as many points as possible. But you notice there's one particular point that is out, that is quite far from everyone else. Yeah. There's one point that's very far. This is the third point, 33.2 and 32. The rest, they're about the same. They're all on the line of best fit, right? Okay, so I think I can use this, right? So remember, two things we should do from the graph. We should find the gradient and the y-intercept. So I can see, and if you, another thing is you should read the whole question. The question mentioned here, if you read the last line here, this one, use the graph to find the value of r and t, and the correct value of y if one of the y value has been wrongly recorded. So we know there's one value y that's wrongly recorded, which is this point here. Okay, and we're supposed to find the correct value. Okay, but before that, maybe we find the value r and t first by finding the gradient and the y-intercept from the graph. Okay, so my gradient, I'll pick 2 points, and for me, I always take y-intercept. This one you can see is 14.5. It looks like 0, 14.5, and let's pick 5 boxes across. Go 5 boxes across until here. This point looks like 5, 35, 35, 36, 37, 37.5. Yeah, it looks like 37.5. Okay, in between. So your gradient will be 37.5 minus 14.5 divided by 5 minus 0. Okay, let's count. Okay, let's take 37.5. Let me move this here. 37.5 minus 14.5 divide 5 minus 0. This will give us 4.6. So my gradient is 4.6. My y-intercept is 14.5. Okay. All right. So we need to then go back to this equation here, and we need to compare. Yeah, convert the equation to linear form. This y equals to r over tx plus square root r. Let me do it here because I don't have enough space. Y equals to r over tx plus square root r. Okay, right. Now I need to multiply everybody by x, y, because you can see you're plotting x, y versus x. So when I multiply by x, this will be xy. This would be r over t plus square root r times x. The r over t can I put in front, at the back, r over t put at the back, the square root rx I put in front. So you can see that this is your big y, this is your gradient, this is your x, and your c. So what I need to do is to compare my gradient from my graph and the gradient from my equation. My gradient from my graph earlier we calculated is 4.6. I hope you can see is over here, 4.6. The gradient is 4.6. Y-intercept is 14.4. So I'm going to compare this here. My gradient is now square root r and is 4.6. So to find r, we take 4.6 and we square it. 4.6 squared gives us 21.16. Yeah, r is 21.16. And to find your y-intercept, we know y-intercept is r over t from the equation. From the graph is 14.5. Since I know my r, 21.16 divided by t is 14.5. To find t, we take this 21.16, I divide 14.5. My answer is 1.459. Yeah, 1.459. Okay, one more thing. I need to find the correct value of y. The value of y that's wrongly recorded is this 32, right? So we know it has to be on the line here. So let's just zoom in a bit. When your x is 3.2 is here, right? Your correct y value should be from the graph. I got 29. This is 29. Okay. So yeah, we need to read like this. We know from the graph, your xy value should be 29. Since this happened when your x is 3.2, your x is 3.2 here. You can draw this down. This is 3.2. So let's sub in 3.2 y equals to 29. To find my y value, let's take 29 divide 3.2. My answer is this 9.063. Correct the four significant figure, 9.063. Okay. Okay, moving on, question 7. This is from the chapter vector. So here we have a quadrilateral OABC, where O is origin. Point P lies on AB, such that the ratio AB is 3 to 4. That means this is 3, the whole thing is 4, this should be 1. Yeah, your AB is 4, so PB should be 1. Now, at the same time, Q lies on OC such that OQ is 2 to 3. Maybe I put Q here. This is 2. The whole thing is 3, so QC should be 1. Okay, so I know Q should be here. Okay, suppose to find AB in terms of U and V. Okay, so let's start. AP, to go from A to B, right? We know AP is 3 over 4 of AB. AB is the whole thing. AB is a quarter, 3/4 of it. Now we know AB, we can find by going this way. AB, we can go minus U plus V. Minus U plus V. So let's do this. Minus U plus V. Well, we can expand the bracket, right? And maybe I'd like to put the positive in front, the negative at the back. But if you don't do that, it's okay, right? You can put negative 3 over 4 U in front, positive 3 over 4 V at the back. It doesn't really matter. Okay, next, I also need to show that OP equals to this, 1/4 of U plus V. So OP, if you want to go from O to P, we can go from O to A plus A to P. O to A itself is U. A to P is 3 over 4 V. Then you minus 3 over 4 U. When you subtract, maybe I put U first. 1 over 4 U, 3 over 4 V. Okay, so that is your OP. Next one, how do I find PQ? Well, to go from P to Q, we can go P to A to O to Q. Or maybe we can just use this method, P to O to Q. Yeah, we go P to O directly since we already know OP, right? This is P to O. Then we go O to Q. We know OP, right? So PO is negative OP. Yeah, your OP is this. So I put a negative in front of 1 over 4 U plus 3 over 4 V. You can put a negative in the bracket like this, or we can straight away change this to minus. Just multiply inside straight away, right? So it's minus 1 over 4 U minus 3 over 4 V. And my OQ, we know, is 2/3. You see, OQ is 2/3 of my OC. And since I know OC, right? My OC is given as W. So this is 1 over 4 U minus 3 over 4 V plus 2 over 3 W. Okay, so I got my vector PQ. All right, now, then they say it is given that 5 times of PQ is 6 times of BC. So let's continue with part B here. 5 times of PQ is 6 times of BC. Now we know PQ. PQ is negative 1 over 4 U plus, sorry, this is a minus 3 over 4 V plus 2 over 3 W. And BC we can find directly. BC is quite easy. We can go B to O, O to C, right? B to O is minus V. O to C is W. So what we can do is to expand the bracket, right? Let me expand this. This is negative 5 over 4U minus 15 over 4V plus 10 over 3W equals minus 6V plus 6W. Now, in this case, you're supposed to find W in terms of U and V. So we are making W as a subject. So we bring this over, bring the rest to the left. Okay, so when I bring the V over, now a bit hard to see. You can use a calculator if you want. Minus 5 over 4 U minus 5 over 4, 15 over 4V plus 6V. This will be 6W minus 10 over 3W. 6 minus 10 over 3 is 30, 6 times 3, 18. 18 minus 10 is 8 over 3W. I write on the left. Whereas these two, you can add them up. These two I can add up. 6, let me do 6 times 4, 24. 24 minus 15 is 9 over 4V, followed by 5 over 4U. Okay, now it's quite an ugly number, I would say, but doesn't matter. We just multiply everybody by 3 over 8 because we want to find W in terms of V and U. So when you times with times a 3, 9 times 3 is 27, and 4 times 8 is 32. Okay, again, 5 times 3 is 15U, and 4 times 8 is also 32. So whether you want to put it together or separately is up to you. It's okay one. So you can put it together like this, 27V minus 15U over 32, or you can write them separately as this. Yeah. Okay, moving on to question number 8. So the first part is differentiation, second part is integration. So here we have a curve y equals x power 3 and y equals negative x squared plus 2. So we're supposed to show or state which curve produces a gradient less than 0 at point A. Okay, actually you can see the curve that gives us the negative gradient happens here for the second curve. Because the gradient is going downwards, the first one, the gradient is going upwards, but we have to show, so I have to differentiate one by one. For the first curve, y equals to x cubed. So when we differentiate dy dx, this gives us 3x squared. Now at point A, x is 1. My dy dx will be 3 times 1 squared, which is 3. My gradient here is more than 0. For the second curve, y equals negative x squared plus 2. When I differentiate dy dx will be minus 2x. When I sub x with 1, my dy dx will be minus 2 times 1, which is minus 2 less than 0. So therefore, the curve that gives us a negative gradient, is y equals negative x squared plus 2. Okay, Roman 2. Find area bounded by the curve y equals x cubed. Okay, so y equals x cubed is this curve, right? And then second one, y equals to minus x squared plus 2. Maybe I highlight here. And the third boundary is your y-axis. Y-axis is here. So you can see the area bounded by these 3 lines is here, the area in between. So we basically take the bigger one minus the smaller one. The bigger one is here, this line, this curve, y equals to minus x squared is above. Yeah. The smaller one will be the red line, or y equals to x cubed here. So we basically integrate the big one minus the smaller one from 0 to 1. Okay, so the area of the big one is 0 to 1 minus x cubed plus 2 dx. You minus the smaller one, 0 to 1 x cubed dx. Okay, let's integrate that. This will be minus x, increase the power by 1, 3 over 3. Integrate 2 is 2x. Lower limit 0, upper limit 1. Same here, when you integrate this, increase the power by 1, 4 over 4. Lower limit 0, upper limit 1. So let's substitute, put 1 inside, minus 1 over 3, plus 2, put 1 inside, then you minus. If I put 0 inside, the whole thing is 0. I put 1 inside, I get 1 over 4, then you minus 0. So your end result is actually 2 minus 1 over 3. Let me write here, 2 minus 1 over 3 then you minus 1 over 4. So my answer is 17 over 12. Yeah, you can write 17 over 12. Or you can change the mixed number. If you don't change, it's fine. 1, 5 over 12. 1, 5 over 12 square units. Okay, let's move on to part B, still under integration. So here we have a curve y squared equals to x that intersect straight line x equals to k. So you're supposed to find the value of k where the region bounded by the curve, this is the curve, y squared equals to x equals to k, which is this line here, and the x-axis is here. All right, maybe I use a different color purple. Yeah. So actually a region is, actually they don't have to mention x-axis. They don't have to mention x-axis actually. So if you notice that the region is actually here, we should say the whole thing, right? Shouldn't mention the x-axis because one thing I hope you understand the difference between 180-degree rotation and 360-degree rotation. So if you view from here, right, if you have only a single line, you need a 360-degree rotation to get a complete solid. If your axis is in the middle, but this graph you can see is symmetrical, you see two lines here, one on top, one below, you only need 180 degrees to get a complete solid. The one on top rotate, it ends up here. The one below rotate, it ends up here. So this is your shaded region, the region bounded by the curve and the line x equals to k. Yeah, like I say, you should ignore the x-axis of the question. Maybe should not mention x-axis. Yeah, should not mention paxi x or x-axis here. And when you rotate 180 degree, you get a complete solid. So there's no difference whatsoever to your formula when you calculate. We integrate pi x y squared dx. Your y squared is already 2 dx, lower limit 0, upper limit k. The result is 9 pi. Now notice your y is already squared here. So you don't have to square this 2x. Your y squared is already 2x. So we can actually cancel the pi and pi. As I integrate this, I get x squared over 2. The 2 can cancel out. This is 0 to k. The result is 9. Okay, let's sub inside k squared minus 0 equals to 9. K squared is 9. Square root of 9, k is 3. Now, do you have to put plus minus? No, because k, as you can see, is on the right-hand side of the y-axis. So k is more than 0. K is just 3. Question number 9, this is from the chapter Circular Measure from 5 chapter 1. So this is one of the most interesting questions from this paper. Now, here we have a diagram that shows a polygon with 12 sides centered at O. ABCDs are the center for ArcBS. Okay, maybe I will highlight ArcBS. This is ArcBS here. Can you see? They say the center is at A, so you can just join this together. Join this together. Okay, it looks like this. Okay, you're supposed to find the area of shaded region in terms of R. Okay, for me, right, I want you to look at this when you divide this, because I hope you can see that number one, if you want to find okay, maybe I join this first. You can see this, right? This is a sector of a circle, right? The center is at A. If you join this, what do you see? You see that, let me write here, part A, your AO or OA is actually the same as AP, is actually the same as OP. So these three are 3 equal sides. So what is the significant? We know this angle should be 60 degrees. It's an what we call equilateral triangle. So triangle AOP or OAP is equilateral. If it's equilateral, we know this angle OAP is 60. So what is the significance of finding 60 degrees here? Because we're finding the area of shaded region. Okay. Now, if you notice that your shaded region, we can break it up into 6, should I say 8 equal parts. Okay. Now, let's focus on one of them. Let's look at this one. Look at this. This is your shaded region, correct? You can find this shaded region. I can find this shaded region here by taking a triangle here minus a segment. So I need to find this segment first. That's why I identify this angle here. And I know this angle is 60. The radius is not given. They say radius OA is R. So I leave it as R. We're supposed to find area shaded region in terms of R. So we know we have to find area of this triangle minus this segment. This is your segment. Then you can find this blue region here. But the question is, how many blue region do I have here? I have 8. Now you can count. This is 1. Let me label here. This is 1, 2, 3. Cut it into half. 4, 5. Cut into half. 6, 7, 8. There are 8 of them, right? So basically, take a triangle minus segment. Whatever you get, you times 8. Okay, but for this area triangle, also, I hope you know that when we form a regular polygon, I hope you remember this is a form 2 work, right? Regular polygon. If you want to draw a hexagon, should I start with pentagon? Pentagon is 5 sides. We take 360 divided by 5. We get 72. So we know this is 72, 72, 72, 72, 72. Then we join this together, we get a regular pentagon, right? But this is not pentagon. This is a 12-sided polygon. So we know the angle at the center should be 360 divided by 12. That gives us 30. Now I hope you can see. Maybe I use some brighter color, like, okay, not bright enough. Maybe I use purple. I hope you can see that this is one side. Okay, if you have 12-sided, right, you need to divide into 12. 1, 2, how do I do 12? Okay, 2, 3, like this. This is 6, right? Yeah. So if I join this together, we are actually getting a 12-sided polygon. Sorry, very ugly. One side is 360 divided by 12, which is 30. So this purple region here is 30, right? This triangle here, let me just highlight here. This should be 30. So I will start off by finding area of triangle, which is half r squared theta. My radius r squared sine 30. Okay, I hope you remember this area triangle, we actually use half AB sine C. Your A and B are the same. They're both radius, right? Because if you join it to the center, the radius is actually R. This is R, right? This is also R. So everything you connect to the center, they are all R. They have the same radius here because this is equilateral. This is R as well, yeah? Okay, we can calculate sine 30 using calculator. Sine 30, calculator in degree mode, gives us half. So you times half. This is 1/4 R squared. Okay, as for area of segment, let me continue here. Your segment, which is this part here, I'm calculating area segment now. Formula is given by half R squared theta minus sine theta. I hope you remember this, half R squared theta minus sine theta. My R is still an unknown. My theta for this segment is 60 degrees, but you got to convert to radian, so it times pi over 180. Now this is sine 60. I'll just write 60. Yeah? Okay. Half R squared. I know this is pi over 3. 60 divided 180 is pi over 3. Sine 60, you can use your calculator. Sine 60 is sec 3/2. Okay, sec 3/2. And when you multiply inside, this is 1/6 pi R squared minus sec 3/4 R squared. So therefore, area of your shaded region will take the triangle 1/4 R squared minus your segment 1/6 pi R squared. So this one you can put a bracket or you can just change to a plus straight away. This whole thing you multiply by 8. Okay, so it's up to you. A question didn't specify, a question say use 3.142. So we can just use 3.142 straight away if you want. Okay, let me just type in the calculator. 1/4. Okay, drop the R squared first. You minus 1/6, right? Your pi is 3.142. Drop your pi your r square, then you minus cert 3 divide by 4. This one I made a mistake, it's 4, not 2. This is 4, cert 3 over 4. Okay, so whatever we get here, we multiply by 8 because there are 8 parts of it. Okay, sorry, maybe I typed wrongly somewhere. Where's my bracket? 1 over 4. I think I missed out a bracket here. Sorry, there's a bracket here. 1 over 4. I need to open another bracket. Open the bracket. Did I miss out another bracket? I need another bracket in front. Yes, this one. Another bracket. There you go. 1.275. 1.275. So your answer is 1.275 r squared. No choice, we have to leave in decimal because you're supposed to use 3.142. Okay, so don't need to leave in terms of pi or cent. Okay, next one. Find the perimeter of the shaded region. Okay, so now that you are okay with the area, so I'm going to rub this off. Perimeter shaded region, given that r is now 10. Okay, similar to area, right? Your shaded region consists of 8 equal parts of this. Okay, let me just draw this like just now. I've shown you that this is 1, right? One part of it. For area, right, I just find this shaded region, I times 8. For this perimeter, we take 1 of this. This is 1, 2. You want, you can times 2 lah. Times 2. The question is, how many of these do I have? I have 4 of this. 1, 2, 3, 4. Hope you can see that, right? So this arc we already know is 60 degrees. This arc, whether you draw the other side, this side doesn't really matter because it's the same. This is also 60 degrees. We already know this is 60 degrees, right? So we need to add the length of AQ. AQ is your the base here. This is your or you can say in this case just now I wrote DP. DP, AQ are the same. So how do you find the length of DP? If I were to use this triangle here, see, let me focus on this triangle. We know the radius is R, and your R is now 10. We know this angle is 30. We are finding DP. Okay, so here we can use the formula for chord, although this is not exactly a chord. Right? I hope you know, you've probably seen this before. Every time you have a isosceles triangle, for chord is true because chord is actually a isosceles triangle. Let's say this radius R and R. Let's say this is theta. We slice in the middle and we call this length from here to here is X. So this is, let's say, example chord AB. So half of this theta is theta over 2. If you use sine theta over 2, you should get X over R. So your X is now R sine theta over 2. Your chord AB is 2R, 2 times of X. This is also X. Yeah, 2R sine theta over 2. So this is a chord, right? Now, but this, although it's not a chord, but we can apply the same thing because these two are equal length. It's an isosceles triangle, okay? Let me just leave it here first, but this is not part of your answer. I'm just proving or showing you how we derive this formula. So if you want to find the length of DP or AQ, DP is the same. It is 2R. Your R is 10 sine theta over 2. Your theta is 30, half of it 30 over 2. Okay, so that's the length of AQ. Okay, let us find perimeter of one of this. Perimeter of one of this is given by 2 times of your arc. Okay, maybe I do one by one. I don't want to make things too complicated. Let's do one by one first. 20 sine 15. This is 15, right? Sine 15. Yep. Change to decimal. 5.176. 5.176. Okay, cm. That is your AQ. If you want to find your arc, length of arc, let's say OQ, we know we can use S equals R theta. Your R is 20, R is 10. Theta is pi over 3 because it's 60 degrees, yeah, remember? And because the question asks us to use 3.142, so I have no choice. 3.142 divide by 3. This answer is 10.473. 10.473. So your perimeter Okay, let us count this part first. This one, one of this. Okay, it consists of two arcs. So 2 times of 10.473 and 2 chord, 2 AQ. AQ is 5.176. So this represent one region like this. But the question is how many regions that this I have? I got 4 of them. 1, 2, 3, 4. As you can see, just multiply by 4. So let's just count. So we can say this is 2 times 10.473 plus 2 times 5.176, right? Whatever I get, I times 4, my answer is this 125.2. 125.2 cm. This is perimeter. So the answer, the unit is just cm. Okay, this is question number 10. Now, this question is a bit confusing and let's get started. So here we have Ali that ride a motorcycle for a certain distance from his house and stop at several pit stops. The first distance is 10 kilometers from his house. And the difference between the distance between each pit stops are equal. Okay, so first of all, okay, this is his house. The first pit stop is here. All right, the first pit stop, let me call it S. The distance between every pit stops are the same. Okay, maybe I just want to make it a bit different because we don't know what is the distance between each pit stop. So, but they are equal. Let me draw a bit longer so we can see. So the distance from his house to the first pit stop is 10. Then 10 kilometer. And then they say the difference between each pit stops are equal. That means these two are equal. They're all equal, right? So this is the second pit stop. This is the third pit stop. Okay. Now, then they say if the third pit stop is 90 kilometers from the first pit stop, that means we are talking about the distance from here to here is 90. So here's the confusing part. What is part of your arithmetic progression? This is arithmetic, we know. We look at it, it's arithmetic because the distance are equal. So understand this. Your arithmetic progression is actually this, the distance from his house. This is your T1. This is your T2. This would be a D, common difference. This would be a T3, isn't it? The distance from his house, because you keep increasing, right? Like for example, T1 is 10, T2 is T1 plus D, T3 is T1 plus 2D, right? So now, number one, we have to find what is the value of D before you find the distance that he stopped. Yeah, they say the distance Ali stopped on the 20th pit stop from his first pit stop. Okay, so first of all, we know our A is 10. And we know the difference between the third and the first pit stop is now 90. So T3 is A plus 2D. A plus 2D. T1 is just A. The result is 90. So 2D is 90. D is 45. Okay, the common difference is 45. So we keep increasing by 45 between 45 kilometers from each pit stop. Okay, so we want to find the distance where he stopped on the 20th pit stop from the first pit stop. Now, here's the annoying part. The distance that we're talking about is T20 minus T1 from the first pit stop. You're not talking about from his house. It is from his house is T20. From the first pit stop, we're going to minus 10, right? So this will be what? A plus 19D minus A, which is 19 times D. What's your D? 45. Okay, calculator. 19 times 45. What do you get? 855. Yeah, 855 kilometer. Okay, B. Yeah. So I know it's a bit confusing and you might not agree with the marking scheme because if you read the marking scheme, they use something else. All right. So the difference between the distance Ali stopped on the 20th pit stop from his first pit stop. That means we are talking about part B. We are referring to this distance, 855 kilometer. And the sum of distance Ali stopped at the 8th pit stop. Okay, so this is a bit confusing here. What do they mean by sum of distance? Are we talking about total distance? If you're talking about total distance, it's not S8. is T8, right? It's T8 because we see if you travel, by the time you reach the third pit stop, what's your distance travel? T3. By the time you reach the eighth pit stop, what's your distance travel? T8, right? So it's a bit confusing. And here they didn't say the distance measured from the first pit stop, right? For your part B, it's clearly stated the difference between the 20th and the first, it is stated. This one didn't say. It says stop at the 8th pit stop. The distance, sum of distance when he stopped at the 8th pit stop. So naturally, we think this distance measured from his house. If it's a distance measured from his house, it's T8, right? So the question is a bit confusing here. So what's your A? Your A is 10, N minus 1 is 7, your D is 45. So I will take 10 plus 7 times 45. This answer is 325. So that's why if you check the marking scheme, it is going to look a bit different, right? It's going to be a bit different from what we are doing, what I'm showing you here. So the difference would be 855 minus 325, answer 530 kilometers. Okay, so it's not SN. We cannot say SN because you're measuring the total distance travel is T8. Total distance travel in the first 8, by the time you reach the 8 pit stop, it would be T8, not S8. Yeah, okay. So lastly, given the total distance travel is 850, Ali has 250 in cash. He spent 10 ringgit every time he stopped for a break. So if the cost is the cost sufficient or not, show by calculation. So again, it's not T, it's not SN, it's TN. So we start by saying TN must be less equals 850. All right. So because we can write equals, doesn't matter. Now I know some of you may say, is it equal? Is it not? Okay, it's okay to write equal. We use A, which is 10. N minus 1, your D is 45. We find out how many pit stops he made from his house, from the first journey, first time he stopped until 850 kilometers. So we take N equals to 850, you minus 10, you divide 45 plus 1. Yeah, simple linear equation. So we take 850 minus 10, divide 45, then you add 1. So after doing so, you got N equals to 19.67. So obviously your N cannot be 19.67, right? N is an integer, so your N should be 19. Yeah, so that means you stop 19 times at 19 pit stop. When you cover a distance of 850, right? He didn't stop exactly at the 20th pit stop or the 19th pit stop. He stopped at the 19th pit stop, then he traveled a little bit more until he reached 850 kilometers. So that means he stopped 19 times. If he stopped 19 times, how much he spent? So the amount that he spent, each time he stopped, he spent 10 ringgit. So he spent a total of 190 ringgit. He has 250 ringgit. So answer is he has sufficient money. Yeah. Sufficient money. Yeah, to cover his costs. Yeah. Or his cost of his expenses is sufficient. Yeah, just say sufficient money would do. Okay. All right. Very interesting question. Okay, question number 11. So here we have a random variable x. X follows a binomial distribution with mean of 5 variance of 4. This is from 5 chapter 5 binomial probability distribution. So the first part is you're supposed to find the value of n and p. So we know the mean, right? Your mean is mu equals to np, right? We know np is now 5. I call it equation 1. And variance is npq. We know npq is now 4, equation 2. So what I need to do is to take equation 2 divide equation 1. So when I do that, npq divide np gives us 4 over 5. We can cancel your np and np. You get your q. Q is 4 over 5, or you can write 0.8. Okay, one thing to take note that p plus q is always 1. So if you know your q is 405. Your P will be 1 minus 405, 1 over 5. But we're finding P and you're finding N. So to find N, we sub inside equation 1. I know P is 1 over 5. This result is 5. Multiply up, my N is 5 times 5. We shall write this as 25. Okay, next, I want to find the value of Px equals 2. Yeah, use the answer to find Px equals 2. So this is a binomial. We know our N, we know our P. For Px equals to 2, remember the formula for binomial? Let me write over here. Is given by Px equals to R, N, C, R, P power R, Q power N minus R. So my N is 25. You see 2. Your P is 1 over 5 power 2. Your Q is 4, 5 power 25 minus 2, which is 23. So here we can use this normal calculator to count, right? That's 25. Let me write here. 25 C2 multiply with 1 over 5 square. You multiply by 4 over 5 power 23. Yeah? Okay, my answer is a big number, 0.0708. 0.0708. You can also use this scientific calculator, this class quiz calculator, which is a lot easier. You press mode, press 7, go to binomial PD, go to number 2 for variable, right? Then your X is now 2, your N is 25, your P is 1 over 5. There you go. My answer is same, 0.708. You want, you can use more decimal point, 7084, right? Okay, so let's look at second part. Okay, the second part, we have a normal distribution here. All right, so we have this is an orchard produces watermelon. The table shows the grading of watermelon. So more than 6.5 kg is grade A, between 3.5 and 6.5 is grade B, grade C is between M and 3.5. So they say that the masses watermelon produce normally distributed, mean for 4.5, variance is 1.21. So if your variance is 1.21, your standard deviation is square root 1.21, which is 1.1 kg, right? Okay, they say a watermelon is chosen random, find the probability is grade B. So grade B means it must be between 3.5 and 6.5. So we need to standardize this. Remember the formula for standardization is Z equals to X minus mu over sigma. Okay, my X is 3.5. My mu is already given as 4.5. So I minus 4.5, divide standard deviation 1.1. So the most standardized, we don't write X anymore, we write Z. 6.5 minus 4.5 divide 1.1. Okay, so when I standardize this, 3.5 minus 4.5 is actually 1. So basically, we're taking 1 divide 1.1. This is negative, so it's negative 0.909. Negative 0.909. 3 decimal point will do, because your mathematical table can read Z value up to 3 decimal point. Second one is 6.5 minus 4.5, which is 2. 2 divide 1.1. Maybe I can just take this and multiply by 2. This will be 1.818. Yeah, 1.818. So I hope you know how to read. If it's in between negative 0.909 and 1.818, the whole thing is in the middle. So I need to use total 1 minus the left-hand side is negative 0.909. I flip to the right, becomes positive 0.909. Then you minus 1.818. So it's 1 minus PZ more than 0.909 minus PZ more than 1.818. Okay, now here we can read from mathematical table if you want, but personally, I find mathematical table a bit slower because you have to really find one by one like this. So I want to show you how to use your calculator, since most of you have at least this calculator, right? Yeah, the silver one. Even the gray one, 570 MS, also can do the same. So you press mode, you go to 3 for stats, right? You press AC. So here we press Shift 1. Remember your calculator, you have to find 5 for distribution. Your calculator read R as the upper tail. Okay, this calculator, like most calculator, they read P as the lower tail, R as the upper tail, and Q as the middle. So if you want to use upper tail, like I want to use PZ more than 0.9, I have to press 3 for R. Then I type in 0.909. Then I get this answer 0.1817. 4 decimal point is good enough. 0.1817. As for 1.818, again, I can just use this. 1.818. 1.818. You will get 0.0345. 0.0345. Now let's do 1 minus of this. Okay, 1 minus 0.1817 minus 0.0345. There you go, 7838. Yeah, 0.7838. Okay. Some of you may say, how about this calculator? Well, this calculator is so good that you can actually do directly without standardizing it. However, because in the process of standardizing it, because we round off correct to 3 decimal point for your Z value, sometimes your answer might be different as a result. But I would still recommend for exam purpose, because you want to get marks for your working, right? Yeah, so I would suggest you do this, right? Of course, you have to standardize, change to do 1 minus, and calculate this, right? So, but if you want to do it one shot using this calculator, you press Mode, you go to 7 for distribution, go to number 2 for normal CD. All right, here your lower is 3.5. Lower limit is 3.5. Your upper limit is 6.5. Your standard deviation is now 1.1. Your mean is 4.5. Okay, your answer will be the same. Can you see? 7838. Yeah, it's so good. But if you want to count, like, if you want to read PZ more than 0.909, you can also do the same. Just change your lower limit to 0.909. But remember, if we say more than 0.909 like this, right? Your lower limit is this. Your upper limit equals to infinity. So when you type upper limit, this is your 909, lower limit. Your upper limit, you put infinity. But we can't type infinity, you put 999. 999 is infinity. Yep. Standard deviation has to be 1. When you use a standard normal distribution, your standard deviation is 1. Your mean has to be 0. Notice you get the same answer, 0.1817. Yeah, it's the same, right? So, yep, we can use this calculator as well to calculate this 1 by 1. Okay. All right. Done. Next, if 98% of the watermelon can be graded, find the value M. So we know if anything more than M, you will have a grade, either minimum grade C, we can get grade B or grade A. So we need to find what is the value of M. This is B Roman 2, B Roman 1. Okay, so we know X more than M is 0.98. Yeah, 98% can be graded. In decimal is 0.98. So we have to standardize this. We take M minus your mean, 4.5, standard deviation 1.1, 0.98. So the problem is we cannot read 0.98 from your calculator. We know obviously this one has to be on the left. M minus 4.5 divided 1.1. This area is 0.98. Your mathematical table can only read the upper tail for value less than 1. If you don't believe me, come, let's look at your mathematical table. All the probability is less than 0.5. Yeah. Okay. So you cannot read this directly. So what I have to do is I have to find from here. This is 0.02. Okay. How do I do that? I can write Z less than M minus 4.5 over 1.1. 1 minus 0.98 is 0.02. So I have to read from the mathematical table 0.02. I'm sorry, if you have this calculator, you cannot. It cannot do backwards. Yeah, it cannot do an inverse norm. So you have to use a mathematical table. Where 0.02? Let's find 0.02. The closest I can find. So we find slowly from here. 0.02. The closest I can find is this. But I need to subtract. I need to subtract 2 from the last digit, which is this one. Now we can find this between this or the next one. Doesn't matter. So this is 2.0. 2.054. I hope you know how to read this. 2.0. The second decimal is 5. The third decimal is 4. Because we need to subtract. We need to subtract 2 from the last digit. You can see this 0.20. Sorry, 0. Should I erase this once again? This is 0.0. This is 0.0202. We want to subtract the 2 from the last digit so that we can get this, right? So to subtract the 2, I have to subtract here, but when you read 2.054. But if you're lazy to do this, you say, I don't want to use mathematical table. What are my options? Your option is to get this calculator. All right. You press mode, go to 7 for distribution, go to 3 for inverse norm. Your area is 0.02. You should get the same. 2.054. But take note that this calculator is what they call that is programmed such that the area is measured from lower tail, but your mathematical table is based on the upper tail. As in, if you read from your mathematical table, 0.02, we are referring to this. This is 2.054, right? But your mathematical table, this calculator, it has a negative because it's reading 0.02 from the left. Therefore, it gives a negative in front. Okay. So anyhow, for this question, we have to flip to the left because your z value is on the left, right? So remember, you need to put a negative 2.054 because it's on the left-hand side. Okay, maybe I highlight here. This is on the left-hand side. See that? So you're going to flip your z value to the left. Otherwise, you get a different answer altogether. So now we take 1.1, you multiply by negative 2.054, then whatever you get, you plus 4.5. There you go, 2.24. So your answer must make sense. So your answer must be less than 3.5. Your M should be less than 3.5. In this case, it's 2.241. Yeah, your M is 2.241. Okay. Okay, question number 12. So here we have, this is from the chapter Solution of Triangle from 4 chapter 9. So here we have a solid prism with horizontal rectangular surface EFGH. Trapezium ABFE is a uniform cross section. So we're supposed to find angle BAF. Okay, so a bit hard to see from here. So BAF is this triangle here. BAF. So, but before you find the angle for BAF, we need to find the length of AF and length of AB. So, let's say I start off by drawing this out for you. This is your, I think I find AF first. AF is quite easy. This is your triangle FEA. This is 10. This is 6.26. I can find AF. This is a right angle triangle. I can find AF by using Pythagoras. Okay. So my AF will be, let me just write down here. AF is 10 square, 6.26 square with the square root. Okay. 10 square is 100. 100 plus 6.26 square. Let's put the square root over. Okay. You should get 11.80. 11.80. Okay, I also need the length of AB. So, but you need to move this down. We can see that this is 10, right? So if I draw a line across, let's call this N. And this is 4. You move it down, this is also 10. So I'm going to redraw this triangle. This triangle is ANB. My NB is still 10. My AN will be 6.26 minus 4, 2.26. My AB, I have to use Pythagoras again. 10 square plus 2.26 square, put the square root over. Okay, so let's count. Take this. 10 square, sorry. 10 square is 100 plus 2.26 square, put the square root over. This answer should be 10.25. Yeah, 10.25. Okay, once you got these two, we can now find angle BAF. So I'm going to redraw the triangle ABF. So B is here, F is on top, A is over here. I'm finding this angle. Okay, maybe I draw a bit bigger, a bit small here. Draw a bit bigger, like this. This is F, this is B, this is A. So AF we know is 11.8, AB we know is 10.25, FB we know is 4. Okay, so to find this angle, I'm going to use the second version of cosine rule. I hope you all know cosine rule works like this. A square equals B square plus C square 2BC cos A. For me, I'm going to rearrange it. I bring the 2BC cos A over, bring the A square over. So your B square plus C square minus A square is now cos A. The 2BC, I divide it. So this is the second version of cosine rule. We rearrange the equation because it's a lot faster to do it this way to find angle BAF, right? BAF. So remember, A is your opposite. B and C are the other two given side. In this case, it's 10.25 square plus 11.80 square minus opposite length 4 square over 2, 10.25, 11.80. So here I'm going to use my calculator. Okay, I'm going to calculate this way. Open bracket with a fraction 10.25 square plus 11.8 square minus opposite 4 square divide by 2 times 10.25 times 11.8. So whatever we get, shift cos answer equals 19.3. So angle BAF is 19.3. Okay. First part, no problem. Okay, second one. How do you find angle DCG? DCG. Okay, for angle DCG, right? Maybe I redraw for you because actually DCG is the same as ABF because this is a uniform cross section. I know a bit hard to see. DCG is the other side. It's the same cross section, right? So DCG is the same as ABF. So by finding angle ABF, I can find angle DCG. So let's start by finding ABF, okay? So we use sine rule because I know this angle now, 19.3. I know the opposite length, so I'm going to write sine angle ABF divide 11.8 equals sine 19.3 divide by 4. Okay, let's use a calculator. Sine 19.3 divide by 4. I multiply by 11.8. Whatever I get, shift sine answer equals. Okay, but remember, this is obtuse angle. We can see quite clearly it's obtuse angle. So we cannot say ABF equals to 77.17. We need to do 180 minus 77.17. This result will be 102.83. Yeah, you can't use brain, use calculator. 180 minus this 102.83. And like I say, angle ABF is the same as angle DCG. Yeah. So we write here, therefore, angle DCG is 102.83. All right. So the first part A, we're done. That is for Roman 1 and 2. Let's do Roman 3. Okay, area of triangle DFG using Heron's formula. Okay, this part here, I find this a bit ridiculous because DFG, the actually is a right angle triangle. I know it's a bit hard to see, but guys, if you view from the top, what we see is this. This is like a rectangle. It's not a triangle. It's not a square. It's a rectangle. Now, you've learned this in your Form 3, plans and elevation. E sits on top of A. F sits on top of B. G sits on top of C. F sits on top of D. If you're finding DFG, D is over here. Should I highlight for you? DFG. Isn't this a right angle triangle? It is, right? DFG. A bit hard to see in 3D form. You have to view from the top. Okay, now we can actually use formula for area triangle, but the question really says use Heron's law, but you have no choice whether to use Heron's law. But we still have to find a couple of things. We already know your FG. FG is 7.21, no problem. But for the first part, DG, right? Maybe I redraw this for you. This is your HG. This is 10. This is 6.26. Okay, actually, you know DG and AF are the same, right? Okay, I don't have to recalculate this. My DG is the same as AF. DG is the same as AF, which I really got earlier, 11.80. Okay, what I need to do is to find DF. Okay, I need to find DF. Okay, so we know DG. Okay, when you view from the top, DG is like this, DG 11.80, and we know GF is like this, is 7.21. Okay, so what I need to do is to find DF. Again, I use Pythagoras theorem here. Let me write DF. Okay, let me move this up a bit. I don't have enough space. DF will be 11.80 square, 7.21 square, put the square root over. Okay, let's count. 11.8, 7.21, put the square root over 13.83. 13.83. Okay, I got 13.83 here. Okay, so I know my DF already. So the triangle that I want to find is this triangle DFG. I know my DG 11.8. I know my GF 7.21. I know my DF 13.83. Like I said, we actually don't have to use Heron's law. We can use half times base times height and we get the same answer because this is right angle triangle. But since question asks us to use Heron's law, so I'm going to use, remember Heron's law? First, we take semi-perimeter at the length of all three sides. You divide by 2. Okay, so let's count. This is 11.8 plus 7.21 plus 13.83 divide by 2. So this answer is 16.42. Okay, and to find your area, we take the difference between each side with the semi-perimeter. Okay, remember, the formula for Heron's law is S minus A, S minus B, S minus C. And your S is A plus B plus C over 2, the semi-perimeter. So your S here is 16.42. Let's take 16.42 minus your A, 11.8. 16.42 minus your B, 7.21. And third one, 16.42 minus 13.83. Okay, so let's use a calculator. Okay, for me, I will store this answer. This answer 16.42, I'll store it. So I will put a square root answer, open bracket, answer minus the first one, 11.8, close bracket. Second one, answer minus 7.21. Okay, third one, answer minus 13.83, close bracket. There you go. My answer is 42.54. Yeah, 42.54. Okay, now if you use half times base times height, you can see your base in this case, let's say I use 11.8 and my height is 7.21. I'm getting the same answer. Yeah, 42.54. It's a lot easier, right? Don't have to use Heron's law. Okay, now the last part, B. They say line FB is extended such that AB equals to AB prime. Okay, so I extend FB. This AB and AB prime are the same. So B prime should be over here. You're supposed to sketch the triangle of ABB prime, state the angle BAB. So let's draw. This is part B. Let me redraw like this. It looks like it is an isosceles triangle. Let's just draw like this. We'll do. This is your B. this is your B prime, this is your A. Now, previously, we know this angle here is 102.83. Yeah, if you extend here, this is 102.83. So the angle next to it should be this one, 77.17, right? So when you extend, you notice that these two are equal length. AB prime equals to AB. So this is also 77.17. We're supposed to find angle BAB. Okay, so this one you don't need to show, yeah? You don't need to show, yeah? The diagram looks like this. You re-sketch it. And BAB will be 180 minus 77.17 times 2. Okay, let's work it out. 180 minus 77.17 times 2. My answer is this, 25.66. Yeah, 25.66. Okay, that's all. Okay, question number 13. This is from the chapter index number for chapter 10. So here we have a table that shows price indices and the changes of price indices for 4 main expenses during MCO. So the first part, they say, let's just focus on part A here. We are finding the total expenses for food in the year 2020 if the total expenses in year 2021 is RM 720. So if you look at food, right, the index is 120, right? So let me write over here. So I think it's easier, it's better I write here. The price for food in 2021, we know is 720. So you can put RM 720. Price of food in year 2020, I don't know. You multiply by 100, the result is 120. Your index is 120. So to find price for year 2020, we just take 720, you multiply by 100, then you divide 120. Bring the E20 up, bring the 120 down. When you divide by 120, your index is, your price is RM 600. Okay. Now, next, this is Roman 1, Roman 2. Now, the composite index for the total expenses in the year 2021, based on the year 2021, okay. So this one is supposed to be based on the year 2020, yeah? 21 based on 20, yeah, sorry. Yeah, the question here is a bit, there's a mistake here. So you're supposed to find the value X. Okay, now we look at the table here. We got all the indices here already. The problem is we don't know what's the weightage, right? Remember, composite index, you have to take the index multiplied with its respective weightages. So your weightages right here is given in the form of angle. So I'm going to put a W for, okay, maybe I put angle here. This is your angle. Okay, for food is 144. For rental and installments 108. For utilities is 72. For miscellaneous is 36. Now notice all this can be divided by 36. So if you're not sure, just use your calculator. 144 divide 36, you should get 4. 144 here should be 4, right? Okay. 108 divide 36 is 3. 72 divide 36 is 2. 36 divided by 36 is 1. So normally I would simplify the weightage. Okay, so it's easier so that calculation wise is a lot easier to count, right? So my composite index, I'm right here, composite index is given as 126.3. Our job is to find the value of X. So we take the individual price index. We start with 120 times with the weightage 4. Your rent X multiply by 3. So you can write 3X. Utilities 150 times 2. 150 times 2. Miscellaneous 108 times 1. Divide by total. What's your total? Oops. Total weightage will be 4, 3, 2, 1. And this is 126.3. Okay, let's count. Let's take 120 times 4 plus 150 times 2 plus 108 times 1. So this answer is 888. So 3x plus 888 divided by 10. This is 126.3, right? Now let's take your 126.3 multiplied by 10, 1260, 1263. Take this 1263 minus 888. Whatever you get, 3x is 375. You divide by 3, answer is 125. Yeah, x is 125. Okay. Not a big issue, right? Okay. Now, next one. Hence, calculate the composite index for total expenses of 2022 based on year 2020. State your interpretation, right? So, we know that there is a change in the price from 2021 to 22. So when we say decrease by 10%, the reduction is, when you drop by 10%, the index is 90. When there's no change, it remains as 100. Increase by 5%, we say the index is 105. No change, again, is 100. So for question like this, when we have two consecutive index given, right? We know this year 2020, this is 21, this is 22. So let's look at example food. For food, right? 2020 to 21 increased by 20% is 120. 21, 22 dropped by 5%, dropped by 10%, the index is 90. To find the overall increment, right? What we can do is from 2020 to 2022, we take 120 times 90 divided by 100. I hope you know about this. This is the simplified chain rule, we call it, right? So 120 times 90 over 100, this will be 108. Yeah, for food, it will be 108. Okay, for rent, it's not going to be any different because why? If you go in times 100 over 100, it's the same. So your rent is the same, remains as X, which is 125. Your utilities increase by 5%. So the index is 150 times 105 over 100. Let's count. 150 times 105 divided by 100. I got 157.5. 157.5. Okay. And lastly, we have miscellaneous. Again, miscellaneous is not going to change because if you have no change from 21 to 22, the index is going to be 108. So now that I have all these things done, I need to find the composite index. So we just repeat the process. I'm going to repeat, I'm going to write here. The composite index will be, let's start with 108 for food. You multiply weightage, your weightage is still 4. Rental, 125, weightage is 3. Then utilities is 157.1. 2. Lastly, miscellaneous is the same, 108 divided by times 1. Your total weightage we already know is 10. So let's count. Let's start by taking 108 times 4 plus 125 times 3, 157.5 times 2, and then 108, whatever I get, divided by 10. So that's 123. Okay, so how can we, give interpretation? The question also says state the interpretation based on the composite index. So remember, this one represent overall expenses. Yeah, your composite index represent overall expenses. So we say the overall expenses has increased by what? Has increased by 23%. Yeah, so that's an interpretation. Okay, lastly, part C. Okay, it is given that at the end, calculate total expenses in 2020. If the corresponding expenses in 2020, you're finding expenses 2022, expenses 2020 is 4,000. So I'm going to do it here. Okay, so price in 2022, I don't know. Price in 2020 is 4,000. You multiply by 100. We already said that the overall expenses increased by 23%. So the index is 123. To find P22, we'll just take 123 times 4,000 divide by 100. So, yep, 4920. RM 4,920. Okay. Okay, question number 14. This is from 5, chapter 8, Kinematics of Linear Motion. So here we have a particle that moves along straight line and passes through fixed point O. The velocity is given by V equals d squared minus 6t plus 8. Yeah. So we are finding the initial velocity. Okay, so I'm going to do here because it's quite short. Okay, I'm doing here. Right. So initial velocity happens when t is 0. When you put t equals 0, you will get 8. Yeah, just write 8 meter per second. When you sub t with 0 here, t with 0 here, your v is 8. Okay, second one. Find the velocity of the particle when the velocity is uniform. Actually, they made a mistake from here because we cannot say it's a uniform velocity. We say either you say minimum, maximum, or we say acceleration is 0. Because if you look at this, this velocity, if I were to sketch it, right, it is a minimum curve like this. So we know that you have a minimum or maximum velocity when your acceleration is 0. It's uniform. Uniform means you go horizontal. That's uniform. Okay. So we can't say it's uniform velocity. We say acceleration is 0, or we can say velocity is minimum, right? Maybe I should use the word minimum. Okay. Right. I hope you know this. In physics, right? If you guys, some of you take physics, right? Uniform velocity means it goes constant. This is not constant. This one, it goes down and up. This is the point where the velocity is minimum. Okay. Now we know minimum velocity happens when your dv dt or your acceleration a is 0. Acceleration is we can obtain acceleration function by differentiating velocity function. If I differentiate t square, I get 2t. I differentiate minus 6t, I get minus 6. Differentiate, it gets 0. When your acceleration is 0, your 2t is 6t is 3. Now, to find this velocity, what we do is we substitute this inside your v. Yeah, this will be 3 square minus 6 times 3 plus 8. Okay, use your calculator. 3 square is 9 minus 6 times 3 is 18 plus 8. Your answer is -1. Yeah, so your velocity is -1 meter per second. Okay, next one. Find the range of values of t for which particle moves to the left. Okay, the particle will move to the left when the velocity is less than 0. Okay, we know our velocity function is t squared minus 6t plus 8. This is less than 0. We can double bracket factorize this. Your factor of 8, we should use 2 and 4, and they are both minus. Let's do a sketch. We know you should get 2 and 4 here, less than 0. The region should be below. We shade the region below, remember? This is using form 4, chapter 2, concept of quadratic inequality. So the range of values of t should be anywhere between 2 and 4. All right. Okay. I think I'll do the last part here. Next, find the total distance traveled by the particle in the first 4 seconds. Okay, to find the distance traveled first 4 seconds, we know the particle actually changes direction from 2 to 4, right? You can see from here that we're done in part C. So if you were to sketch a number line, it looks like this. I start from here, okay, point O. We move to the right. It makes a U-turn and it goes back to the left. We know it changes direction first time when t is 2. It will change direction for the second time when t equals to 4. But it doesn't matter because when it changes direction is here. We don't know. This is when t equals to 4. So we just have to find the distance here minus the distance here. Okay, you can say this is S2 minus S0, S4 minus S2. So some students, they may prefer to find the displacement function first, then they substitute. Or for me, in this case, we can just take the distance as integration, definite integral of your velocity function t squared minus 6t plus 8 dt. From 0 to 2, we put 0 to 2. From 2 to 4, since it's going to the left, we know it's going to the left, because you can see it's below. If this is a graph of velocity time, right? Your velocity is negative, meaning it's moving to the left. When it's moving to the left, the displacement here will be negative. So you put a negative in front, or you can put a modulus, up to you. So this is t squared minus 6t plus 8 dt. Okay, let's integrate. This is t cubed over 3. 6t squared over 2. 6 divided by 2 is 3. There's a t squared. There's a 8t. Lower limit 0. Upper limit 2. This is t cubed over 3. 3t squared plus 8t. Lower limit 0. Lower limit 2. Upper limit 4. Okay, let's sub in. Let's put 2 inside. 2 power 3 is 8. 2 power 2 is 4. 8 times 2 minus 0. This is 4 power 3, 64 over 3. 4 square, 16. 4 times 8, you can write 32 lah. Then subtract 8 over 3. 3 times 4. 8 times 2. Okay, now let's count. This one I just use a calculator. Okay, now first part, 8 over 3. This one I minus 12 plus 8. 8 times 2, 16. This answer is 20 over 3. Keep my 20 over 3 first. Minus the second part. This one we have to recalculate. 64 over 3 minus 3 times 16, 48 plus 32. Now take note that this whole thing is the same as this answer. So I don't want to do a lot of work. I will straight away use the answer that I've calculated earlier, minus answer, negative 4/3. Now take note that the reason why we get negative because it's moving to the left. This is negative 4/3 because it's moving to the left, right? So the first part, the distance traveled, we know is 20 over 3. Second part is negative 4/3. So we put a negative in front to make it positive, right? So 20 over 3 plus 4 over 3, 20 plus 4 is 24. 24 over 3, the distance traveled is 8 meters. Now, you can always validate by using a calculator. Now, do you know that your calculator has this integration function? You can type in alpha x squared minus 6 alpha x plus 8. Your lower limit is 0, upper limit is 2. You can count, it's 20 over 3, right? Then we just change this to 4. Move down, change this to 2. And my answer is negative 4/3. Yeah, so we can validate and we know this is true. This is correct. Okay, last question from this paper. This is the linear programming form 5, chapter 7. So here SMK Taman Nilai, Nilam wants to send few of these SPM and STPM students to participate in answering techniques seminar. So the participants for SPM student is X, number of participants for STPM is Y. They're based on the following constraint. The first constraint, because we know we have to write linear inequality, a 3 inequality, right? Based on the first constraint, total number of participants is not more than 70. So we say X plus Y less equals 70. And not more than 70 means less equals 70. Okay, then they say the number of SPM is X, is not more than twice number of STPM. Not more than twice means less equals to Y. Okay, third, the number of participants for STPM must exceed twice the number of SPM participant by at most 10. Okay, it sounds a bit confusing. STPM is Y, exceed twice SPM. Exceed means you have to minus STPM bigger than SPM. Y minus X, but in this case it's 2X twice. By at most means maximum 10. So there you go, you got these 3 inequality. That's the answer for part A. Okay, second part, we have to draw the graph. Okay, so in this case, before you draw a graph, I like to use a table of values. So let me move this a little bit to the right. I'll draw the table of values over here. Okay, we know the first one is X plus Y equals to 70. I usually like to use X equals 0 and Y equals 0 because these two represent the X and Y intercept. When X is 0, Y is 70. Y is 0, X is 70. All right. The second inequality is, although they say X less equals to Y, I will encourage you guys to think 2Y greater equals to X. Yeah, you can write here 2Y greater equals X because when you shade the region, we're looking at Y, we don't look at X. Yeah, Y more than means above, Y less than means below. So here we take X and Y. When X is 0, Y is 0. When X, pick another number, maybe I put 40. When X is 40, Y is 20. You can use any other figure. Next one, Y minus 2X equals to 10. So if you put X and Y, when X is 0, Y will be 10. Maybe I put X equals to 40, Y will be 50. Yeah, 2 times 40, sorry, y will be 90. Maybe don't put 40, put a smaller value, maybe 20. That would be 40, 50. Okay, as long as we have 2 points, yeah, doesn't matter whatever point you want to use. But the scale is quite obvious. We have used standard in the question, so I think it's stated 10, 20, 30, 40, 50, 60, 70. I need to go up to 70, yeah? Because the largest x value I have is 70. All right, let me draw the line here, from here to here, 70. Okay. Next, let's draw 10, 20, 30, 40, 50, 60, 70. This is your y. Okay, let's draw the axis. Okay, maybe I can adjust a little bit. It's a bit off. Okay, so the next thing is we want to draw x plus y equals 70 first. X plus y equals 70 means it must pass through 70 on x, 70 on y. It's a line with a gradient of -1. So over here, let me zoom in a bit hard to see, right? So make sure it passes through here. Okay. All right, next, y, 2y equals x, x0, y0, x40, y will be 20. So 40, 20 is here. So make sure you pass through this point and the origin. So let's draw from here. Let's pass through this point here. So the first line is x plus y equals 70. The second one is x, 2y equals x, or x equals to y. Yeah? Okay, the third one is 0, 10, 20, 50. 0, 10, 20, 50 is over here. So again, make sure you pass through 0, 10, 20, 50 here. Okay, so this line is y minus 2x equals to 10. So I got these three lines drawn. Now, the next thing is we need to shade the region that satisfy all these three inequalities. Okay, the first inequality, as you can see, x plus y less than 70. So I know it must be below here. Okay. Second one, as stated here, your 2y more than x. So it must be above this. Okay. And the third one, it must be y minus 2x less equals to 10. So it must be below this line. So I know the region is a quadrilateral inside here. And normally we have to shade and label with symbol R. Okay, this is R. Okay, and this is part B, yeah, done. Okay, next, part C, use your graph to find the range of STPM, number of STPM student. But STPM is Y. Yeah? If SPM is 30, if your X is 30, what's your Y? So we draw a line. X is 30, find your Y. When X is 30, your Y should be, this one is 15. Right? It looks like 15 here. 15. Okay, this is 15. And this is 40. Right? So we say that your Y is between 15 and 40. Okay, next, the fees, the maximum total fees needed to be paid by the school for each SPM, STPM participant is, if the fees for each SPM, STPM is 10 and 20. So here we have to form what we call an objective function. Now let me do it over here. SPM is 10, STPM is 20. The result is K. K is your total fees. So we want to find the maximum value of K. So for me, I always change this to Y equals to mx plus C. This is negative 10x plus. This will be K. As I divide by 20, this is negative half x plus K over 20. So to find maximum value of K, I must draw this straight line with a gradient of negative half. And I have to move it in the region. and find a point that gives us the largest y-intercept, because your largest y-intercept, the y-intercept will affect your k value. The bigger the y-intercept, the bigger the k value. But first, let's draw a line with the gradient of negative half. Okay, so for me, negative half, right? You can use 10 and 20, or you can use 40, 80, up to you. Maybe I use 20, 40. Yeah. Normally you can use dotted line, but in this case, I cannot draw dotted line here. I'm just going to draw a straight line here just to show you this is your objective function line. It's not wrong if you use a straight line, but just that normally we use dotted line. Okay, because this is a variable line. This is a line representing your objective function that you're finding. You're finding the maximum cost. So this line is 10x plus 20y equals to k. So it's a variable. I can move it up, I can move it down. I want to find a point that gives us the smallest y-intercept, the largest y-intercept, sorry. So as you can see here, maybe I see if I can copy this. Okay, I take this. So I can copy this, copy, and I paste it. Oh, never mind. It pastes somewhere else. So never mind. We just draw a line. So, okay, I just draw a line to show you that you have a line that is parallel. Okay, around the same. You can use your ruler, move it up, and draw a line here. We can see that this point will give us the largest y-intercept here. But we don't read the y-intercept from here because it's not accurate, because as you move up and down, the line, your ruler may be slanted. So we know the maximum happens at 2050, right? So we say k is maximum at 2050. To find the maximum value of k, sub inside x with 20, y with 50. So this is 200 plus 1,000. The maximum fees you have to pay is 1,200. Okay, we're done for the discussion of this paper. Thank you very much for watching. So I hope to see you in the next video.